eclipses were anciently believed to be caused by a beast or demon swallowing the moon. Now we understand them to simply be infrequent but predictable events in the regular cycle of moving celestial objects in the sky. A lunar eclipse occurs when the moon passes into the shadow of the Earth cast by the sun. To fully understand a lunar eclipse, we must identify two paths in the sky and understand how light works within our solar system. As the Earth orbits around the sun, we can chart the path the sun makes against the background stars. This path is called the ecliptic. We can also define this path as the plane that Earth's orbit makes. Like the Earth orbiting the sun, the moon orbits around the Earth. We can see that the moon's orbit also makes a plane and therefore charts a path against the background stars. But notice, the moon's path is 5 degrees tilted to that of the ecliptic. Our solar system has one light source. It is the sun. Celestial bodies in the solar system get light from the sun, but only on one side. When we see the sunlit side of an object, we can see all, part, or none of the sunlight bouncing from the object, depending on where we are and where it is. This is called a phase. Let's use our moon to demonstrate the phasing of an object. As we watch the moon from Earth, we can see all, part, or none of the sunlight that is shining on the surface of the moon, depending on its orbit. The amount of sunlight we can see reflected from the moon changes over time. This change of light revealed to us is called phasing. The moon is constantly phasing, always changing from new moon, first quarter, full moon, third or last quarter, and back to new moon. This repeats about every 29 and a half days. Notice that during a new moon phase, the moon is between the Earth and the sun, and the sunlit part of the moon is facing away from the Earth. During a full moon phase, the moon is on the other side of the Earth as to the sun, and the sunlit part of the moon is facing towards the Earth. On a night of a full moon, watch the sun set in the west. At this same time, turn around and watch the full moon rise in the east. This simple activity can only be done around the time of the full moon, when the sun and moon are on opposite sides of the Earth. Also notice the reddening of the sunset. This too plays a role with lunar eclipses. Everything that is lit by the sun casts a shadow into space. When we can see the full moon, it is because the moon is either above or below the shadow cast by the Earth. It spends most of its time outside of Earth's shadow. But this is not always the case. Remember, the moon's orbital path and the ecliptic are tilted 5 degrees with respect to each other. The Sun-Earth-Moon system doesn't always line up, but these tilted orbital paths do intersect, and for a short time, the Sun, Earth, and Moon system lines up. This is when we can see a lunar eclipse. A total lunar eclipse can only occur during full moon, when the Sun, Earth, and Moon system are aligned. When the moon's orbit and the ecliptic are not perfectly aligned but close, we see a partial lunar eclipse. Unlike the sun disappearing in a total solar eclipse, the moon does not disappear in a total lunar eclipse. In fact, the moon is not only visible, it takes on a distinctive and somewhat eerie red color. Why? Let's talk about light for a moment. Why is the sky blue? Everyone knows you see a rainbow in the sky after a rainstorm. We see these rainbows as a result of the sunlight passing through the water droplets in the air, bending the light from the sun through the droplets of water like a prism. Redder light has wavelengths that are long. Bluer light has wavelengths that are short, and the rest of the colors are in between. Light travels in a straight line unless something gets in its way. This is what happens with our rainbow. Water droplets get in the way of the light, altering the light. The shorter wavelengths get adjusted or refracted more than longer wavelengths. The atmosphere has water vapor in it at all times, not always to the degree of a rainstorm. This water vapor still adjusts the light. The longer wavelengths of light make it through the water vapor better than the shorter frequencies of light. This scattering of light is called indigo, and it is why we see the sky as being blue. During sunset, and with the increased angle of sunlight, there is more atmosphere to scatter blue frequencies. What does this mean for lunar eclipses? During a lunar eclipse, sunlight is still passing through the atmosphere. The blue frequencies get scattered in our atmosphere, while the red frequencies continue through and head back into space. This is why we see a red moon during a lunar eclipse. To the ancients, a rainbow was meant as a promise to never destroy the earth. And during lunar eclipses, a beast or demon was swallowing the moon. We now know it's just a matter of light. Who gets to see a lunar eclipse? In order to watch the moon pass into the Earth's shadow, you must be in the shadow of the Earth. So anyone on the nighttime side of Earth will see some varying degree of the lunar eclipse. It is possible to view a lunar eclipse at sunrise or sunset. This is called selenihelion, also known as a horizontal eclipse. Lunar eclipses are not necessarily more common or more rare than solar eclipses. It's just that essentially half the planet can experience a lunar eclipse. There are lunar eclipses about every year. You just have to be on the right side of the planet to see them. Talk to your planetarium or museum educator to find out when the next lunar eclipse will be visible from your location. Join us next time for another edition of Starlight Express.